Hey, BC Calculus. This is Mr. Canfield, and a little video for you about integration by parts, about something I did not have a clear explanation for, and so I did some digging and figured it out. So, or got some help and whatever. Here it is. So, let's say we're taking the derivative of u of x times v of x. Let's say we're taking that derivative. We could just write u of x times v of x prime. Well, that's going to be equal to u prime v plus v prime u. You know, just our standard product rule of a derivative. So what would happen then if we integrated both sides? If we integrate here, we can break this up into two separate integrals. Oh, forgot the dx. Right? So if we do that, so over here we'll be left with the integral of this, which is u of x v of x plus some constant. We don't generally write the constant over here. And then over here we have the integral of u prime v plus the integral of v prime u. So we haven't taken these integrals yet. They don't have a plus c, but this integral does have a plus c. And this is where that plus c is coming from when we end up having infinite loop kind of problems. And we have to solve for, we have pieces of integrals and we move one over, and then when I teach this, I generally go, oh yeah, and there's a plus c on the end because we integrated. It came from here. Because now if we rearrange to write it the way that the formula looks, the formula has this by itself, and so it subtracts this from both sides. So I'm gonna write this first. The integral, I'm gonna write the way that we see it in the formula generally. And most of us, when we do the formula, we drop the x's, which is u v prime, or d, or dv, they'll call it sometimes. But this is on the left-hand side. And then over on the right-hand side, we have u of x, v of x. We have to subtract this, u prime v of x. And there's a plus c that's already there. Now, the reason why we don't write it here, I think, is on Wikipedia, it just said we neglect to write this here. And I'm like, why? But I think it's just because it's here, but we're not really concerned with it yet. We're not, this formula that we generally use, we're gonna have to integrate here. We'll get a constant of integration that pops out here, and we don't feel like calling this C1 and then later bringing in a C2. Because the way it would look is you have something here, and then whatever you get there is going to be something plus c, and then we already have this plus c on the end. And so since these constants are arbitrary, we don't know what they are because they could be an infinite variety of constants depending on what our original function is or initial conditions. We just clump them together. Instead of saying this is C1 or C2, we just say, well, it's all some constant together, and we just save ourselves the headache. So that is why we can confidently put a plus c at the end of even a terrible problem. So, got that done in under 5 minutes. Hope it was helpful. And 4:59.